Guys, you are there?
Yes, sir.
For random forest, we are getting same as our decision tree. Right? 95. No, 95, 94 is okay. All of you guys are getting the same?
Yes, sir. I'm getting 0.68.
You're getting 0.68. But how come decision tree and random forest has the same accuracy? Even for 5,000 trees, it is given the same accuracy.
So decision tree also I got 0.68, the same value.
Actually, you got the same value, right? I got the same
Yes.
value, 0.66.
Yes, sir.
No, I think I have taken only 150. You have taken 180, yeah? I think 180 features is not giving us any difference, right? And 180, I got 49. $68.56. I think Hachita, you are taking 180, so don't worry about that because in between I reduced it. Now I've converted it to 180.
Yes, sir.
You're right only. Internet is not working. So we are getting same accuracy for both random forest classifier and RF predict is equal to RF model dot predict X underscore TF IDF. So plot underscore confusion matrix RF comma X underscore TF IDF comma Y. So we got the confusion matrix. There is minor difference 3638. print classification report Y, comma, RF predict. Yeah, classification report is also a little bit different. 69. Okay, all of you done with random forest? So from sklearn dot ensemble import gradient boosting classifier. GBM is equal to gradient boosting classifier and underscore estimators 5000. GBM model is equal to GBM dot fit x underscore TF IDF comma Y. GBM model dot score X underscore TF IDF comma Y. 6856. Predict is equal to GBM model dot predict X underscore TF IDF. Plot confusion matrix GBM comma X underscore TF IDF comma Y. Then print classification report. I comma GBM predict. Okay. Anand, yes, all of you are done till this point?
Sir, just a minute, it's still running.
Yeah. Hmm? Running, your CPU is smaller now, so it will take time to run. Okay, run. Still running, huh? Okay, let it run, no problem. So multinomial neighbors. Oh, 47.42. Hmm. Run. Your CPU is 4 GB RAM or 6 GB RAM? Then you should have given only 2000. Yeah, that's what. No, no, don't do anything now. Let it run. Anyway, neighbor's model has failed. Let's now. GBM only will give you the best accuracy. Online guess done.
Yes, sir.
So neighbors is also not giving us good accuracy. So neighbors is not giving us. So let us see support vector machine. %60 SVM. So print classification report by comma SVM predict 60%. From sklearn dot neighbors 3%. Five neighbors, 50%. KNN also not giving us good accuracy. Still running, huh? No end. Accuracy. Take a break, okay? Guys, online guys, you also take a break. So MLP classifier is giving us the confusion matrix and all, with 68% accuracy. 50, 25, 10. Oh shit, we have to give more than, na? Our input is how much? 180, right? 200, 100. We have 180 variables. Which graph? Huh? See, we are looking at confusion matrix. No, only these diagonals are there, no? They are correct predictions. Rest of all are wrong predictions. The diagonals, yeah, hello? ఏదో వచ్చిందమ్మా. యా, వాళ్ళు కాల్ చేశారు, హెచ్డిబి నుంచి కాల్ వస్తుందని. యా, యాక్చువల్లీ సాఫ్ట్వేర్ ట్రైనింగ్ చేస్తూ ఉంటాం. ఓన్ ఫామ్ ఉంది. కాదు కాదు, కంపెనీ రిజిస్టర్డ్ కాదు. we use Python programming. Okay, so in robotics, they should know Python programming. That is one thing. Second thing is, if the robotics also is using machine learning algorithms for making decisions. Because in some parts, they use the robot has to make some decisions. Suppose the robot has to make some decisions. There are different types of algorithm. They have machine learning algorithms. They also have some search and sort algorithms are also there. So it depends on what he wants to do. Yeah. So if you are looking at the robotics AI course, he can do in weekends robotic AI course. I think IIT Hyderabad has a weekend course. That's for online only. Weekend courses there IIT Hyderabad or Triple IIT Hyderabad. I'm not suggesting. IIT Hyderabad also I don't suggest, but cost will be less and it's a reputed thing, no? Even BITS Pilani Hyderabad or BITS Pilani is also offering weekend programs, robotic and AI. See, the problem with robotics and AI, I'm telling you frankly, is when it comes to machine learning and deep learning, Python data science guys will teach you. Okay. And what happens in robotics is there is another thing called search and sort algorithms. They are advanced mathematical algorithms, which mathematical guys have to teach. In India, we don't have a good trainer in search and sort algorithms. They are purely mathematics based algorithms. But in advanced robotics, machine learning and deep learning is used. Neural networks is widely used because most of the times the decision has to be made, right? It will be based on deep learning or ML. So whether he wants to go there, if he wants to go into that part, then he has to learn statistics, mathematics, and data science, all the algorithms he has to learn. If he wants to stick to the programming side, Python programming or data engineering and all those things, then he has to do Python programming, full stack Python. We call it as full stack Python. So full stack Python is completely like our Python data science. There will be a lot of modules. So Python for web development, Python for app development, Python for sensors, Python for Unix, Python with Unix, Python with C++ and C, Python with Java, Python with databases, all those things will be there in full stack Python. Full stack Python will take 1 year. 1 year minimum. And you must be comfortable with Java and C. Java, C and .NET. So full stack Python, little bit difficult. It's pure programming. But job opportunities will be very high. Payments will be very high. Full stack Python. Python programmers, there is huge requirement. Yes, online, we also got the same 66. Now I think neural network is giving us higher this thing score. If I increase the iterations to 2000, see if there is an improvement in the score. .47, not much score increase. If you increase the iterations, score is not increasing. So neural network is doing well. Okay, word level TF-IDF has higher accuracy compared to n-gram levels. Word level TF-IDF has a higher accuracy compared to n-gram. So let us check whether that is there or not. I will go to my TF-IDF vectorizer. I will remove the n-gram range. Oh, we have 45, 55 also always. Hmm. 63% logistic regression, drastic improvement if you take word level. 95.4 if you take decision tree classifier word level. So all of you change the remove the n-gram range. In TF-IDF vectorizer, remove the n-gram range. Because if you look at here, in one of the articles of Analytics Vidya, they have used word level TF-IDF, they have also used count vectorizer. For count vectorizer also, they got good accuracy, 70%. Word level, that means single word, 70%. But when you use n-gram is what we were using, not two words. The accuracy fell to 53%. If you are using character level vectors also, the accuracy is 68, 72. So what we can do is, if you are doing a machine learning problem, always use word level TF-IDF. Word level TF-IDF means do not give n-gram range. Do not give n-gram range. Okay, let n-gram range be 1, 2. 1, 2 means one word only. It will take only one word. So just go to your TF-IDF vectorizer definition and remove from TF-IDF vectorization n-gram range. Remove n-gram range, delete it, and keep other things as it is. So here in TF-IDF, remove n-gram range. Remove n_gram_ range as the accuracy is low per n grams. Accuracy good for single words. So accuracy is good for single words. So we will be using what we call single word vectorizer. So these things you need to understand, right? So simply we sometimes bigram range works. In this particular data, word ranges are working because if you look at our, see, now you can see all are single words. All are single words. We have two numbers here, 45 and 55. We can delete them also, no problem. Or we can keep them, that's not an issue. Then dict of tokens, you can see the TF-IDF scores. Then once I ran the logistic regression, I got an accuracy of 63. Initial logistic was 49 only, right? Now it went up to 63. Now decision tree, it went up to decision tree is 95.46. Okay, and confusion matrix also looks good. Precision F1 scores all are looking good. For random forest also, oh, I gave 5,000 estimators. Oh, that's the problem. Okay. So we will give less estimators and then we will get good accuracy. One comma means you give it as a word. 95.46, okay. 43, yes. Because it is correct. So if you remove it also, by default it is 1 by 1 comma 2 only. N-gram by default is 1 comma 2. Online guys, you're understanding, right?
Yes, sir.
So word
Sir.
level TF-IDF, not the N-gram level. N-gram means more than one word. RF mode also 95.46 for me. For me 95.691. Oh shit, GBM also it ran with 5,000. So word level we are using, not the N-gram level, okay? That you keep in mind. Okay, 95.46 GBM, NIBIS 56, no improvement. Then SVM 80.69, good score. ANN 61.92, not much improvement. MLP classifier, it's running. Ninety-five point 32. 94, yeah. Because random, na, slight difference will be there. And check your iterations also. So neural network with word model is the best fit model. Okay. So all of you got this? But it is taking time, right? GBM is also good fit. RF is also good fit. But what is the time of computation? All of them are 95. You got GBM, RF, and neural networks 95. But which one is working faster? Neural networks. So you have to look at time. When they have equal performance, you have to look at the time to how fast they are responding. That is why I'm saying neural network will be a best fit model. So in SVC, gamma is there. What is this gamma? So gamma is equal to scale. Kernel coefficient for RBF, poly, and sigmoid. Gamma is equal to scale or gamma is equal to auto. So if we can improve the process of SVAC, gamma is equal to auto. Oh, gamma is equal to auto drastically affected it. So you remove gamma is equal to auto. Gamma has to be scale only. $80.69. Okay, guys, all of you got this NLP notebook. We have done it on Zomato reviews. Okay.
Could you explain the hidden layer sizes? Like,
Yeah.
how
Hidden
do we
layer
determine it?
See, the first layer will be the input layer. If you remember, the input layer should be greater than your number of variables. We have 180 variables. So I have given input layer as 200 neurons. The number of neurons in the input layer should be greater than the number of variables, greater than or equal to. So we have given 200 input layer, what you call, we have 180 input. So the first hidden layer, I have given 200 neurons. 180 inputs, first hidden layer with 200 neurons. Then I have compressed it to 100 neurons. Then I have compressed it to 50 neurons. What compression will do is it will reduce the number of features passing through the network. Thereby, it also increases the accuracy of the model. When it is, how it will compress? By eliminating features or variables which are closer to zero or which are considered least important. So what it will do is the compression layer will eliminate those features which are not significant. So from 200 to it goes to 100 neurons. From 100 neurons to it goes through a layer of 50 neurons. it will give you a compressed network. So compressed network will finally takes in only the critical features, and then the accuracy of the model will increase in compressed networks. We call this as compressed network.
Okay, sir.
Okay.
Understood.
So I am reducing it by half. First layer neurons are 200. Second layer, I just made 50% of the first layer, which is 100 neurons. Third layer, 50% of the previous layer, again 50 neurons. Now, there are no fixed rules for how to decide neurons. It is more about trial and error and grid search. Any doubts, participants? So the typical process is this. See, the typical prediction process in data science is, in NLP is this. In natural language processing, the typical process is this. See, we take the text document. Actually, there should be a pre-processing here. Once the pre-processing done, we have to use vectorization methods. There has to be a pre-processing here. Actually, pre-processing should be there. Without pre-processing, we can't do the vectorization methods. Vectorization methods means you have count vectorizer, TF, IDF vectorizer, bag of words vectorizers. There are a lot of vectorizers in academic, but in Python, we have two, count and TF, IDF. Then from these vectorizers, you will generate the feature vector or independent variable matrix. And then we will apply machine learning classification algorithms. Then we'll get the final classification model. So after text, there must be pre-processing. So before vectorization, you have to do text pre-processing. So what is text pre-processing? Text cleanup. Text cleanup like remove what? Digits, punctuations, special characters, etc. Stop words. All these things will come under your text pre-processing. So before vectorization, you have to do text pre-processing. So this is the process of natural language NLP or text mining. So in NLP, we worked on web scraping, we worked on tweets, we worked on reviews. Reviews are also similar to web scraping, but what is happening nowadays is all the websites have blocked the scrapers. So we have to depend on the reviews given. But then you can access the latest reviews of Airbnb. You can work on Airbnb reviews is there, no? Very interesting review data is there, Airbnb reviews. So you can upload this as an NLP project in your GitHub. I think there is no, not of an EDA, you can't do much of an EDA here. So You can only do purely NLP on this reviews data. If you want any live data, we can use Airbnb reviews or Yelp reviews. So Yelp open data set. So it's a very large data set. It's a very, very large data set. If you are interested, you can work on this. You can download the data set. So we have images data set, but we will download the JSON data set. JSON data set is related to our text data. 4 GB is the data size. You can imagine how much big is the data. So this is a very interesting data set. So what if you're looking at what is Yelp, it talks about all, it's like our, it gives you reviews about everything, restaurants, home services, auto services, dry cleaning, for like, you have this Just Dial, na? Just Dial. Just Dial is a copy of Yelp. Just Dial is a copy of Yelp. Or that yellow pages thing is there, na? Sureka or something is, Suleka or something is there, na? But Yelp is the pioneer of these pages, Yelp, YELP. They are very, very famous in US, Yelp, YELP, Yelp. So the data set is very, very large. I will pause this because there is no internet now. I am working on my mobile data. I will download it at home and I will share with you the data. Because my mobile is very slow. Similarly, Airbnb reviews data set. Where you have that reviews.csv file where you worked earlier, right? That also is there. Yelp, any small data set is there. Same data set is here. So this is the method to convert the JSON file into a data frame. Pardon? Yeah, it's very large data. You can't use basic machine learning models. So this guy use word2vec. Word2vec is a deep learning methodology. We'll talk about word2vec when we talk about deep learning. See, NLP, analytic stop words, stemmer, tokenizer. Then he has done the tokenize 1 lakh, GenSim models, fast text, window 5, vector size 300, min count 5, epochs 10. Clean review, progress per fast text model, train clean review, works fast. See, 45 lakh, no, 4 crore, 50 lakh, 55,810. Positive and bad. So word to vec we'll discuss when we talk about deep learning. But this is a very large data set. If you are interested on working large scale natural language data, use Google Colab only. Don't use your system. Let us see. Help CHI data, Chicago data. Okay. Reviews data set. So help.csv. See, there is the review text. Okay. So what models? NLP, sentiment analysis, help reviews, naive bias ratings, same thing, fake review detection. Wow. Fake review detection, how did you do? Multinomial NB, random forest classifier, decision tree, SVM, gradient boosting. Yeah, same thing. I think this guy is my student only. Because he ran all the models which I taught them earlier on NLP. So guys, any doubt in NLP? Medicare is also there. There you have to look at the description. You try it, no? Only on description, do the vectorization. There the description is very smaller. See, in Medicare data, the description is very smaller. This is the Excel sheet, right? So this is the thing which you need to run on. Like what we did in review, na? So we have to work on this text. The biggest advantage here is the words are similar. Look, anesthesia, biopsy, procedure, lens, surgery, retinal. So the text is very similar. Here, only stopwords is required. There are no special characters and all. So you can just look at this data, remove the things in the brackets and all, and then remove the stop words, and then use the thing to create a TF-IDF vectorizer. And then once you create the TF-IDF vectorizers, all the keywords should come. Injection, biopsy, all this anesthesia and all should come. Once you have that data, you can easily, I think I have already sent it, right? Oh, I have not sent the data. Okay. Medicare data, I have not sent it, right? No. Geo.csv. So you can work on this data, right? You understood, right? And then you can use other variables. You can do you have numeric variables now? Check for multicollinearity on the numeric variables. total standardized amount, average settlement amounts, there are numeric variables. So you create a text variable, this binary variables here, TF, IDF vectorizer, and then you add those numeric variables also. Okay, and then before adding numeric variables, you have to do multicollinearity, correlation analysis, and remove those variables that are having multicollinearity. And then you can convert it into a regression problem, where you can predict average standardized procedure amount. Online guys, any doubts? Online guys, any doubts?
No, sir.
So tomorrow we will work on the analytics with the data set, okay, competition data. Okay. So that's the regression data. We will practice all regression models. Guys, here internet is not working. I'll go and upload all the videos now. Think I have not uploaded from June 7th. No, sorry, not from June 7th. August 1st. So I'll upload all the other videos. Okay, after going home, because there is no internet here. I am working on the hotspot. Okay. Any doubts?
No, sir.
Okay, can we end the session for today?
Thank you, sir.
Thank you, sir.
Thank you. Thank you all for participating. Thank you very much.
Thank you.
Thank you, sir.
Yeah.